A student is investigating the stretching of materials. The student applies varying loads to material J and determines the stress and strain until it breaks. The experiment is then repeated for a second material K. Figure 2.1 shows how the stress for each material varies with strain. Compare the materials J and K using figure 2.1 and the 6 terms listed below, and include in your answer an explanation of each term. Alright, so let's start with the definition of all of these terms. So brittleness is the ability of a material to break or shatter without significant plastic deformation. Ductility is the ability of a material to deform under tensile load. Tensile meaning applying tension, so pulling it. Elasticity is the ability of a body to return to its original shape and size when the distorting force is removed. Plasticity is the ability of a material to undergo permanent deformation before rupturing. Ultimate tensile strength is the maximum stress a material can withstand. And finally, Young modulus is the gradient of the linear portion of a stress-strain curve, and that's related to the stiffness of the material. So now let's compare these two materials using the terms that we have listed below. So K is brittle, it doesn't undergo any plastic deformation. J does undergo plastic deformation. That starts to occur soon after the linear portion of the graph, so around here-ish roughly is where you would no longer have elastic deformation and you will now have plastic or permanent deformation. They both have elastic regions. The straight lines correspond to where the elastic deformation is occurring. J is ductile. Generally for stress-strain curves, the default is we are applying tensile load, we're pulling the material apart. So there is plastic deformation occurring under that tensile load, and therefore it is ductile. So the difference between ductile and plastic, as mentioned down here, but just to be very clear about it, is first of all, they both involve plastic deformation, but ductility is specifically under tensile load. Plasticity is plastically deforming or permanently deforming under any type of load. That could be tensile, so pulling it apart, or pushing it together, or applying a shear force, which is like a twisting force. But ductility is specifically for tensile load, so pulling it. Ultimate tensile strength is the max stress the material can withstand, so J has a higher UTS than K. Young modulus is the gradient of the linear portion, so J has a higher Young modulus. A student is designing a 3-legged wooden stool, as shown in figure 2.2. The stool must be able to support the weight of an adult, so heavy adults are above 100 kilos, let's just say the max is around 150. The maximum compressive stress of the wood is 2.3 megapascals. Estimate the minimum cross-sectional area of one leg. So 150 G is the total downwards force on these 3 legs. Divide that by 3 to get the force on one leg. So that's F. Stress is equal to force over area. So area is equal to force over stress. This is our maximum compressive stress, sigma. So do the force of 50 G divided by the stress of 2.3 times 10 to the 6 pascals. And we end up with an area of about 2 times 10 to the minus 4.